Okay, Year 9, I'm going to do today rationalising the denominator. Now, before I even start with rationalising the denominator, you need to know why. And the reason why is because we need to be able to operate with fractions. Now, fractions that have, as you can see here, have a surd in the denominator, they're not easy to work with. Trying to do fractions where you've got a surd in the denominator and you're trying to get common denominators, or you're trying to do adding or subtracting or multiplying or dividing, it's difficult. So we want to get the surd out of the denominator. So when we talk about rationalising surds, we're making the denominator a non-surd. Now, we're only going to do single surds in the denominator. We are not doing these. We're not doing those. So if anyone starts talking to you about conjugate, that's for next year. In Year 9, we're just doing rationalising a monomial denominator. That means it's only got a single surd in it. There's no adding or subtracting. So we just have to make sure we can do this. And all we're going to look at is questions 1 to 4. Now, the way it works, it's best if I do this via an example, but essentially we're going to be using this law. We're going to be using that root A times root A equals A. And every time I write a surd, and I write a surd or two surds together, like in algebra, there is a multiplication sign between them. So again, if I look on Google Classroom, we'll see that I want you to do the last column. I'm going to do the third column. So I'm just going to do these questions from the third column in questions 1 to 4. If you want to do the third column and follow me, that's fine. But if you want to try and test yourself, do the last column, because usually the harder questions are towards the end in the last column, so you'll always hit the last one. But otherwise, I'm happy for you to just do the ones that I do. So let's begin. So I'm looking at 1D. And what have I got? I've got 3 on root 7. So what I'm going to do is I'm going to multiply top and bottom by root 7, by the surd that is on the bottom. Now, I haven't changed anything because root 7 on top of root 7 is just 1. So I haven't changed, I've just changed how it looks, but I haven't changed the integrity of the fraction. Now, 3 times root 7, that's pretty easy. 3 root 7. Root 7 times root 7 is 7. Now, whenever you talk about learning intentions and success criteria and things like that, our success criteria can basically be this sort of stuff here. What do I do? How do I achieve success? Well, number 1, you multiply the numerator and the denominator by the surd that is in the denominator. Well, that's okay. Simplify the surd in the numerator if you can, so up the top. If there's a way to simplify it, like to pull out square numbers or cancel anything. And then finally, you cancel any common factors. So they're our success criteria. And this is our learning intention up here, rationalising surds or fractional surds. So we've multiplied by the surd in the denominator. There's no way I can make root 7 simpler, and I can't cancel out any factors top and bottom. So that's done. Let's try the next one. And remember, I'm doing the third column, so I'm doing I. And I've got 3 on 2 root 5. Now, you could multiply top and bottom by 2 root 5, but that would just complicate things. Just multiply top and bottom by, and I should have had a vinculum up here, root 5 on root 5. Okay, on the top, I get 3 root 5. On the bottom, I get 2, and root 5 times root 5 is 5, so I get 2 on 5, or 2 times 5. Well, that's 3 root 5 on 10. Nothing can come out of the root 5, and I can't cancel any of the factors of 3 and 10. So that one's done as well. Just double checking. So on my other computer, I have my answers. What are these? This is 1, D and I, but I'm pretty sure I'm right. So 8, 6, 1, D, 3 root 7, and I, 3 root 5 on 10. Let's have a go at N. Now, I get a surd on top. And I get 3 root 11. Now, don't let that surd on top do anything to you. Just let it go. I'm going to multiply by the surd in the denominator, root 11 on root 11. Well, root 6 times root 11, root 66. And that's where I get my kicks. I've been waiting for that. Root 11 times root 11 is 11, so I get 3 times 11. Now, root 66, I don't think I can bring root 66 down. I don't think there's anything that I can cancel out of root 66, so that stays. And 3 times 11 is 33. All right, now when we get to question 2, we're going to get some cancelling here. So here, I'm going to start 2D. And again, I'm doing the third column. You can choose what you want to do. You can do the last column, or you can do the third column. Now, the first question is 10 on root 5. And again, all I do is multiply by the surd in the denominator. So root 5 on root 5. Now, when I do that, root 10 times root 5, that's just 10 root 5. Root 5 on root 5 is 5. Now I can cancel because 5 goes into itself once and 5 goes into 10 twice. So my final answer is 2 root 5 all over 1. But I don't need to write the all over 1. I. Now remember, if you're watching this and you're doing these questions, stop the video, have a go at the question, make sure you're getting it right. Here I get 5 on root 30. Now again, I'm going to multiply by the surd in the denominator. So I get root 30 on root 30. I now 5 root 30. I don't think any of the square numbers go into 5 root 30. I'm pretty sure, what are we? 2i. No, nothing's going to come down. Now, root 30 times root 30 is 30. And again, I can cancel here. 5 goes into itself once and 5 goes into 30 6 times. So my answer is root 30 on 6. N. 9 on 4 root 6. Okay, so I just multiply by the surd in the denominator, root 6 on root 6. Remember, the whole point of this is to get a rational denominator. 9 root 6, 9 root 6. Root 6 times root 6 is 6, and I've got 4, so 4 times 6. Now, you can multiply and then cancel, but I'm going to cancel straight away because everything is multiplied. 3 goes into that twice, and 3 goes into that 3 times. So on the top, I get 3 root 6. And on the bottom, I get 8. Now, I could have multiplied that 4 times 6 and got 24, and then done 3 into each of those and cancel. But I just like to cancel as early as I can. S. So I'll do S here, to S. I've got 12 root 5 on 5 root 6. Remember, ignore the surds on the top. It's just the surd on the bottom that tells you what to multiply by. You've got to get rid of the surd in the denominator. Don't care about the numerator. So we just multiply by root 6 on root 6. Now, we get 12. Root 5 times root 6, root 30. I've already seen that over in a previous one. I can't cancel root 30. On the bottom, I get 5 times 6, because root 6 times root 6 is 6. And now I cancel. 6 goes into itself once, 6 goes into 12 twice. So my answer is 2 root 30 on 5. Final one, x. 3 root 6 on root 2. Now, I see, you can't forget what you learnt previously when multiplying and dividing. I don't need to rationalise this, because I know that I can just cancel straight away, because root 2 goes into itself once and root 2 goes into root 6 root 3 times. So I get 3 root 3 on 1. Now watch what would have happened if I had done that by rationalising. 3 root 6 on root 2. I'm going to multiply by root 2, root 2. You watch how complicated this gets now. Root 2 times root 2 is 2. On the top, I get 3 root 12. Oh, but root 12 is the same as root 4, root 3 over 2. But the square root of 4 is 2. So 3 times 2 root 3 over 2. And the 2's will cancel, leaving me with 3 root 3. Much easier. Don't forget what you already knew. And you knew that from your multiplying and dividing. Question 3. I'm just going to create a little bit of space for myself here to do question 3. So I'm just going to grab all that and get rid of that. And I'm going to grab as much as I can of that and get rid of that. Oh, come on. Why don't that grab that? Okay. So question 3. What have I got here? And remember, I'm doing the third column. So 3c. 3 plus root 7 on root 5. All right. Just look at the denominator, root 5 on root 5. Now on the top, you've got to remember that you're multiplying everything here. So this is like a binomial expansion. I've got to do 3 times that and root 7 times that. So I'm going to get 3 root 5. And root 7 times root 5 is root 35. On the bottom, I get 5. Now, you don't go trying to cancel anything now. Be very careful. These two are added, and you can't cancel. I can't cancel anyway. There's nothing that goes into those. I can't pull anything out. I suppose I could do a little bit of factorising, but I'm not going to. I'm just going to leave it like that. So that's 3c. Let's have a go at 3g. They're getting complicated now. 3 root 2 plus 4 over 2 root 5. Again, just look at the denominator and look for the surd. Root 5, root 5. Now again on the top, You've got to remember that it's root 5 times both of those things. So I'm going to write it out so you can follow what I'm doing. I'm going to get 3 root 2 times root 5 plus 4 root 5. And on the bottom, I get 2, and root 5 times root 5 is just 5. Well, 3 root 2 times root 5, that's root 10. 4 root 5, can't do anything with that. 2 times 5, 10. Now, be very careful. Some of you will be tempted to cancel there and there. No, you cannot, because they're not multiplied. If you're going to try and cancel, you've got to cancel out of both things on top, and there's no number that goes into 3 that goes into 10. So you have to leave G like that. Okay. 3 root 5 minus 20 on root 10. Okay, so I'm going to multiply top and bottom by root 10. And what do I get? Now remember, again, I'm going to multiply those two by root 10, because that's... So, again, I'm going to write it out long. I'm going to get 3 root 5 times root 10 minus 20 root 10. And on the bottom, I get root 10 times root 10, and I'm going to get 10. So then I get 3. Now, I can multiply that. Yeah, it's going to be easier. I'm just going to write 3 root 50. There is another way. I'll show you in a minute. And here I got minus 20 root 10 over 10. But I know that root 50 is the same as root 25 times root 2. Remember when we did simplifying? You can write root 50 as root 25 times root 2. And the square root of 25 is 5. By the way, you don't have to write all these steps. If you know that you can just multiply those 5 and get 15 straight away, go for it. I'm writing this out so that people are able to follow. Okay, and 3 times 5 is 15 root 2 minus 20 root 10 over 10. Now, because I've got things in both, I have to cancel out of both of those. Okay, 5 goes into 10 twice, 5 goes into 20 4 times, 5 goes into 15 3 times. You have to cancel out of both parts. Okay, so I get 3 root 2 minus 4 root 10 over 2. And let's just double check what question was that. K, and I'm looking at 3K, 3 root 2 minus 4 root 10 on 2. And remember, you can always use your calculator to check. Now, I said there was an alternate way to get from this step to that step. And I'm going to write it here. I'm just going to do the 3 root 5 root 10 bit. Well, 3 root 5, I can write root 10 as root 5 root 2. And root 5 times root 5 is 5, so I get 3 times 5 root 2, which gives me 15 root 2. Same answer. Same answer. You don't have to multiply and then look for a square number if you can see the factors in it. Okay, Question 4, and this is as far as you go. This is what it's all about for adding and subtracting fractions. So let me create some space again. Here we go. So to add and subtract fractions, I need common denominators. Now I know you could get common denominators with surds, but then it gets really difficult. It's much easier. You can do it, but it becomes so hard. So don't try and get a common denominator. So in the first one, if you're looking at 4c, you go, oh, I'll get a common denominator of root 22. Yeah, great. And then you have to rationalise root 22. It's much easier to rationalise first. So here I go with 4c. And I've got 2. And when you do this, do the same as me. Root 11 and leave a big gap. Plus 3 root 2. Because what you need to show is when you do this, you need to show what you're doing. So root 11 on root 11, that's going to rationalise that. I'm going to multiply by root 2 on root 2. Okay, let's have a look at the first one. Just this fraction. I'm going to get 2 root 11 on 11. Now, let's look at this one. And I'm going to get 3 root 2 on 2. And now I look for a common denominator. So when you did all that stuff, all that work, learning how to add and subtract fractions, you go, oh, why do we have to do this? I can always use my calculator. Yeah, well, I suppose you can use your calculator for this because you have surds, but you're not going to get an exact answer. You need to be able to add and subtract fractions. So I'm going to make a common denominator. I'm going to multiply this one by 2 top and bottom, and this one by 11 top and bottom. So 2 times 2, I get 4 root 11 on 22. 11 times 3, 33 root 2 on 22. And now I have a common denominator, and I get 4 root 11 plus 33 root 2 all over 22. Now, in the future, I'm going to skip that step because as soon as I've got a common denominator, I will write a single fraction. It's much easier. Now, if you're doing the same column as me, you stop the video, have a go at G, and then see how you went. You don't have to actually look at the video. You can check the answers if you've got this now. So I've got root 2 on root 5. I'll leave a bit of a gap, plus root 7 on root 3. And I'll leave a bit of a gap. I'm going to rationalise, so I'm going to multiply that by root 5. I'm going to multiply that by root 5. And this I'm going to do root 3 on root 3. On the top of the first one, I get root 10 on 5. And on the bottom, I get the second one, I get root 21 over 3. I'm going to make a common denominator. I'm going to multiply this by 3. The common denominator is going to be 15. I'm going to multiply this by 5. Away we go. Now, I told you I was going to skip that second step because as soon as I know the common denominator is 15, I just write 15 and I'm going to put the first part here and I'm going to put the second part here. I don't need to write them as separate fractions. So I'm going to get 3 times root 10 and I'm going to get plus 5 times root 21. It just means I skip a step. Like if you look at these two steps, I'm going to get rid of some of this stuff now. Oh, I got rid of the wrong one. 3 root 10. This thing and this thing are exactly the same. They're just separate fractions. So I will be skipping that. Okay, one more. By the way, I suggest very strongly that if you get this and you followed me, you try one on your own from the last column. So I've got 5 on 2 root 3 minus, oh, sorry, I should have left a bit of a gap, minus 4 on 3 root 3. Okay, I'm just going to multiply this one by root 3. I'm going to multiply this one by root 3. And look what happens over here. Oh, root 3's again. So this is going to be interesting. So here I get 5 root 3. And root 3 times root 3 is 3. I've got times 2 there. Minus 4 root 3. And I've got 3 times 3. Okay, so that gives me 5 root 3 on 6 minus 4 root 3 on 9. Now, I could multiply by 6 and 9 and get a common denominator of 54, but I can see a smaller common denominator, and that is 18. So I'm going to multiply this one by 3, and I'm going to multiply this one by 2, and I'm going to get a common denominator of 18. So I'm going to get 5 times 3, I'm going to get 15 root 3. Oh, by the way, my denominator is 18. I only need to write a single fraction. Minus 2 times 4 is 8. 8 root 3. Oh, and look at this. They are, like in algebra, like terms, they're like surds. So I can perform that subtraction. I've got 15 root 3s, and I take away 8 root 3s. I'm left with 7 root 3s over 18. And that was K, and I'm just looking for the answer for K. 4K, HIJK, 7 root 3s on 18. All right, that is rationalising. Now, I know I've written success criteria, but when you use a maths textbook, your success criteria are just essentially the instructions, what you need to do to get to the answer. Good luck with that.